And now we're going to talk about one of the most important ideas in calculus, derivatives. So derivatives can be used for many things. One is the rate of change. Of course, as you know in life, everything changes, but derivatives can tell you how fast they change. So for example, as my pen goes across the page, there's a rate of change. As an object goes up and then down, there's also a rate of change. How fast is it going up? Or how fast is it going down? So with this function right here, what we're going to look at is if you substitute x equals 3, that would be a point approximately right here. And then that would be f of 3 for the y value. And then if you let it go until x is 4, that would be a point about right here. And then that would be called f of 4 for the y value. And I just happen to have my graphing calculator right here. I already graphed it. And then I can substitute the 3. So I just go to trace, plug in x equals 3, and the y value is 8. And when I go to 4, the y value is 6. So this one was an 8, and this one a 6. So if you take a straight edge or something like that and connect those 2 points, so right now I'm only looking at the 2 points, and then you connect those two, then you have a secant line. And what we're going to do is find the slope of this red line right here. And then that slope will tell you the average rate of change as it went from here to here. Now it's not exact. As you can see, the line and the function right in here aren't exactly the same, but at least on average from here to here, we can find out the rate of change, or in other words, the slope. So as I'm sure you remember, slope is y2 minus y1 over x2 minus x1. So that's going to be f of 4 minus f of 3, there's the two y values, over 4 minus 3. And then f of 4, that was a 6. F of 3, that was an 8. And on the bottom, that's just a 1. So it turns out that the slope is equal to -2. And since this line is going down, having a negative slope makes perfect sense. Okay, now take that idea, and next what I want to do is, let me just make a copy of it. Copy, paste, but this is the old-fashioned version of copy and paste. So the next thing I want to do is, what if you only have the number 3, and you're at that point right there? And you want to know, as perhaps this was a ball, somebody threw it up in the air and then it starts coming back down. When it's at that point, how fast is it going? So this is basically telling you how fast it's going on average from this point to this point. The negative means that it's going down, and then the units in here could be something like feet per second if we were given units at the beginning. But back to my point right here, what if we only had this 1 point? So then take the straight edge and have it just touch that 1 point right there. And then draw that line. Then what's the slope of that line? When you create one of these using just 1 point, this is called a tangent line. And then how do you find the slope of the tangent line? So it's basically going to start out the same. In order to find slope, we need 2 points. So then what I do is, I go there. This point is going to be 3 plus a little bit. Like in this case, this was a 4, so in that case, h would be a 1. But in general, say it's just a little bit. And then do this formula again. So it's going to be, instead of f of 4, it's going to be 3, f of 3 plus h minus f of 3. And then we need to subtract these two. So that would be 3 plus h minus 3. So when you subtract them, the 3's actually cancel, and you just get this. And then take the limit as h goes to 0. And what this part does is, if this is very, very close to 0, then this point is going to get closer and closer and closer to 3, which would be like having this point get closer and closer and closer to that point until they're practically the same. So then let's go ahead and figure this one out. We'll go ahead and do the work. So the function is, I'm still using this function, negative x squared plus 5x plus 2. And then I need to substitute 3 plus h in for the x's. So then this one would be the limit as h goes to 0. Then there would be negative 3 plus h gets squared plus 5 times 3 plus h plus 2. So that is this part. I've substituted in the 3 plus h. And then minus f of 3, and that was this one right here, that was this 8. So minus an 8. And then on the bottom is h. So now what we need to do is algebra. So I need to go ahead and square this term. So when I square it, there's going to be a 9. When you multiply these two, that's going to be 3h. Double it, that's 6h. And then also square the h, so that's h squared. Then distribute this negative sign. So negative, negative, and negative. For this one, go ahead and distribute the 5, so that's going to be 15 plus 5h. Oops, 15 plus 5h. And then this will be minus 6. And then, to finish this, notice that right here there's a positive 15, and these two together make a minus 15, so they are actually going to get the red pen and cancel. So what's left? So there is negative h squared. There would also be negative 6h's with 5h's leaves negative h, and then it's still divided by h. And then because every term has an h, you can divide all terms by h, reducing it to be negative h minus 1. Another way to look at that is you could factor out an h from the top. And then after you factor out that h, the h on the bottom and this h on the top will cancel, and you'll get the same thing. And then finally, h becomes a 0, so that means this is going to be 0 minus 1, so it equals a minus 1. So in other words, the slope of this red line right here, that's the slope of negative 1. Okay, then there's actually two ways that you can find slope of a tangent line. So you've got whatever function, and previously I just used the number 3, but in general, let's say we're going to use x. And we want to know the tangent line at this point right here. So then you could move over a little bit and have a second point called x plus h. And now that you have 2 points, you can find the slope. So you would take f of x plus h minus f of x, and now subtract these two. So when you take this one and you subtract the x's are going to cancel. It leaves just an h. And then take the limit as h approaches 0. That's one way to do it. Another way to do it is you've got the same function, and then you've got this point x right here. And instead of calling it x plus h, you could call this a. So then you have the 2 points. So you could do the slope formula. So that would be take f of x minus f of a. So subtract the two y values. And then subtract the two x values. On this one, I put x first. So I'm going to have to do that on the denominator. That's the way it's traditionally written. F of x minus f of a over x minus a. This is also called the difference quotient. And then you let x approach a. So actually this point would move over to this one and we'd be finding the tangent line right here. So whether you do it this way or you do it this way, you'll end up with the same answer. Using this definition, for one thing, it'll be in cases like this last one, where you have to multiply things out. If you use this definition, most likely you're going to need to factor. So let me show you an example with this one. So that would be example number 2. Find the slope of the tangent line for the function the square root of x when the a is a 4. So just as a quick reminder, we're using the limit as x approaches a, and then it goes f of x minus f of a over x minus a. When I learn something new, I like to repeat it. And also for me, writing things down helps me to remember them. So in this case, the a is going to be a 4, so we'll put a 4 right there and a 4 right there. And then this is going to be the square root function. So it's going to be the limit as x approaches 4. And then this is the square root function. This is a 4 that you need to substitute into the square root function. And then it's divided by x minus 4. And then it's time to do algebra. So we've got the limit as x approaches 4. The numerator has the square root of x minus 2. And if you substitute the 4, we'll get division by 0. So we need to do something else. The something else we need to do in this case is multiply by the conjugate, which will be the square root of x plus 2. And you need to do that for the numerator as well as the denominator. The next step looks like the limit as x approaches 4. And when you multiply conjugates, you only need the first one times the first one, which will be x. The middle terms are going to cancel, and then there's the last one times the last one, so it leaves x minus 4. And for the denominator, do not multiply it out. And then x minus 4 and x minus 4 will cancel, leaving just a 1 on the top. And so all that's left is 1 over the square root of x plus 2. And now you can go ahead and substitute the 4 because it will no longer cause division by 0. So that's going to be a 2 plus a 2, so the final answer is 1/4. So in other words, if you graph the original function, which is the square root function, it looks like this. And if you plug in a 4, the y value would be 2. And at this point right here, if you draw the tangent line, there we go, then that red line has a slope of 1/4. Or if this was an object that was moving, then the moment that it got to right there, it's going at 1/4 feet per second or miles per hour or whatever the units are. And then for one more example. Number 3. Suppose that you go to the top of the Empire State Building in New York City. The Empire State Building is 1,250 feet up in the air. And then suppose that you were careless or vindictive and you dropped a ball from the top. Then this right here would be the height. This function right here gives you the height, where t is in seconds and then the height is in feet. So then 2 questions. Part A, find the average velocity over the interval from 4 to 5. So from 4 seconds to 5 seconds after you release the ball, what's the average speed that it's going? So this one does not use the limit. This is like the very first example. So we go h of 5 minus h of 4 over 5 minus 4. And for average velocity, when you're given 2 different values to plug in, there is no limit that goes in front. We just calculate this as a slope. So h of 5. So I need to substitute in a 5, and of course I could do that in my head, but I don't want to show off right now. So it's going to be negative 16 times 5 squared plus 1250. That is 850 feet in the air. Now do the negative 16 and 4 is squared plus 1250. And that is 994. And on the bottom, it's just divided by 1, 5 minus 4. So an 850 minus 994 is negative 144. So the negative means that it's going down, and it's going down at 144 feet per second. That's pretty fast. To be able to cover 144 feet in 1 second, I wish I could do that. Okay, then for part B. Well, first, let's take a look at the graph. So negative 16x squared plus 1250. Because I want to know how long is it going to take to hit the ground. So let me look at the window. How about if it goes from 0 to 10 seconds? And then this is height, so 0 to, I need at least 1250, so I'm going to put 1300. So there it goes, and it hits the ground. So this was 10, 9, so let's go with 8 seconds. So right here, how fast is it going? Just about 1 second before it hits the ground. So part B, find instantaneous velocity. In other words, at the instant that it's at 8 seconds, find instantaneous velocity when t equals 8 seconds. So notice the difference is in here, it gives you 2 different values, and you plug those in and you just do the slope formula. That's called average velocity. But for instantaneous velocity, you're only given 1 number, and we need to use the limit definition. So That's where we could use either one of these. Let's see, last time I used this, so I'm going to switch and do this one. So just to remind myself, that's the limit as h goes to 0, and then it goes f of x plus h minus f of x, all divided by h. Now, in this case, we don't have x, so I should have written t, but it's no big deal. This is the general definition. So this is going to be when the variable equals 8. So this is going to be an 8, and this is going to be an 8. So it'll be the limit as h goes to 0, f of 8 plus h minus f of 8, all divided by h. Now I need to take this and substitute it into the function. So that's going to be the limit as h goes to 0, and then negative 16 times 8 plus h is squared plus 1,250 minus, and then when you substitute an 8, so minus 16 8 squared plus 1,250. And then it's still divided by h. And like I said, with this definition, most of the time you need to multiply stuff out, so that's what we're going to need to do here. So in the next step, it'll be the limit as h approaches 0, and I'm going to wait on distributing the negative 16. So you square this as 64, multiply these two as 8h, double that, so that's 16h, and then plus h squared. Now if you notice, there's a 1250 that's positive right here, and then this would say minus a 1250. So they're actually going to cancel out. What I do need is, how much is 16 times 64? 16 times 64 is 1,024. And because of these two negatives, that's going to be plus 1,024. And then we're almost done. The next thing I need to do is distribute the 16 right here. So there would be 16 times 64, which actually I just did that a moment ago. This is 16 times 64, so I know that's 1,024, but it's going to be negative. So there'll be a negative 1,024, and then 16 times 16 is 256, so there'd be minus 256h, and then minus 16h squared. And then there would also be this plus 1,024. And that's right, now it's time for the red pen because these two are going to cancel each other out. And then for what's left, this has an h and this has an h, so you could factor out h, and it would leave negative 256 minus 16h. And that's right, it's time for the red pen. Cancel those h's. And finally, h can become 0 because now there's no more division by 0. So you plug in a 0 right here, all that's left is negative 256, and that would be in feet per second. And that is called the instantaneous velocity. The negative means that it's going down. It's going down at 256 feet per second. I'll see you in the next section.